Okay, YouTube, this is my second video on writing the equations of lines, in which we're actually going to start writing equations of lines. In the last video, we explored the concept of slope. We're also going to do this through the lens of an application problem. So before we do move on to that, I do want to mention a few things. Over here on our left, we have our slope formula, which is our rise over run, or change in y over change in x. But also over here on the left, we have writing the equation of a line, little cheat sheet here. But basically it says, look, if you are given a slope m, if we know m and we know the y-intercept, okay, which is our b value there, then we can actually go ahead and write this in y equals mx plus b form. And I'm rewriting this because it's kind of small written here, written small. But if we know the slope and the y-intercept, then it's very easy to write the equation of a line, because we can just go ahead and substitute those values into here with our y equals mx plus b form, or slope-intercept form. We call that slope-intercept form because we have our slope and we have our intercept, all right? However, if we are given the slope and just some point on the line, some data value here, x1 and y1, then what we're going to use is what we refer to as point slope form. And just like we call this slope-intercept form because it tells us the slope and the intercept, we would use point slope form if we knew a point and the slope of the line. In either instance, I do want to point something out though. It's very imperative that we do know the slope of this line, okay? So you'll notice that in this last instance it says, well, if you're given 2 points on the line, okay, and you don't know the slope, the very first thing we do is use the slope formula to find the slope. But at that point, if we know the slope and we know not just 1 but 2 points, we could just pick one of those points and go back and use our point slope form. So in general, we're usually going to be using point slope form. Sometimes we're lucky we know both the slope and the y-intercept, but we're going to use that to our advantage to write the equations of lines, okay? So let's consider this situation over here. It says this graph shows the distance Allison hikes in x hours. So we have our x-axis down here, and that's representing the number of hours that she's been hiking. What we want to do is write an equation of this line and interpret what the slope would mean in this case, and also answer the question how long it takes Allison to hike 14 miles traveling at the same rate. So I will tell you this, if we had an equation for this already that related hours to the number of miles, or her distance in miles here, then we could just plug in 14 miles and then work backwards and say, well, then how many hours is it? So the goal will be to find the equation of this. And so we notice here that we already have one data point on the graph, okay? And this is the data point 7, 24 and a half. So if we wanted to find the slope of this line, first of all, if we're going to write the equation, we need to find the slope, okay? Then we would say, well, what is the slope of this line? Now we can count rise over run, but what I notice is this starts at 0, 0. So if I said, well, how far up and over did it go to get here? I can tell you that it went up exactly 24 and a half as a rise, 24 and a half. And the run is exactly 7 units in terms of time. So we would say 24 and a half is our rise. 7 is our unit of time, and as a matter of fact, I'm just going to get our calculator out here. If we were to find 24 and a half divided by 7, 24 and a half divided by 7 here. Actually, we'll just use this one. 24 and a half divided by 7, 24.5 divided by 7. This numerical value, 3 and a half, is the slope of this line. So what I want to do is I actually want to interpret this value here, 3 and a half, recalling that this 3 and a half, this top number here, this change in y, is representing a distance. Okay, and the bottom number here, this change in x, is representing a time. So when we talk about, well, what does the slope represent here? How should we interpret the slope? We say that this 3.5 is really 3.5 miles for every hour, okay? 1 hour. And we could express that as just 3.5 miles per hour. But what the slope represents is this. We say slope is a rate of change. Whenever we talk about a linear situation, or any graph really, we say that the slope represents how fast the graph is changing at that point in units of y per units of x. So she's going about 3.5 miles per hour, and it looks like she's got herself on cruise control here because it's a linear relationship. So we say, what does the slope represent in this situation? Slope is the rate of change of y with respect to x. In this instance here, it's rate of change of miles with respect to time. So what I want to say, what does slope represent about our linear situations in general, this is the general statement we're going for. In this particular case, the slope, 3.5, this is really just Allison's speed. Okay, how fast it's changing per unit of time. So when you're talking about a situation like this where you want to find the equation, the very first thing is find the slope of the equation. That's what we're always going to do first. Now that you've got the slope of the equation, what we're going to do is write the equation of the line. Now looking back up here, the question is, do we have both the slope and the y-intercept, or do we have a slope and a point on the graph? Now the case here that I'm looking at is that we have a point on the graph, we have some x1, y1, and we have the slope. So we can use this second formula here, but what I'm going to point out is if you already know the y-intercept, which we do, we know the y-intercept is this value here, 0. Let's just go ahead and say that we know the slope is 3.5, and we know that the b value is 0. We know both of these values. So in terms of writing the equation of the line, I say the y-intercept is already known, so we can write the equation using slope-intercept form from the chart on page 1 of this note sheet, this y equals mx plus b. So we say if the y-intercept is not known, we'll use point-slope form, basically reiterating what I just said. So we say in this case, we say our y equals mx plus b. What we're really saying is this: she's going at a rate of 3.5 miles for every 1 hour, or for every x. So it's going to be 3.5x, where 3.5 is our slope, and our y-intercept we said is 0. So in other words, we could say that this equation could be expressed as y equals 3.5x, or in other words, her distance is always equal to 3.5 times the number of hours she's walked, okay? So now that we have this equation, what we're going to basically do is use this equation to make predictions of outputs for given inputs. And I say or vice versa because notice that our question here says, how long does it take Allison to hike 14 miles when traveling at the same rate? Now they've given us a data point here, but the question really is, okay, are we plugging this 14 miles in for y, or are we plugging it in for x? And recalling that distance or miles is represented by our variable y here, and recalling that what we're looking for here is how long, what is our time, basically we've been given a y and we're asked this question, so how long would it take her to do this? And before we actually use a substitution to find this, I want you to just interpret the graph here. If we said 14 miles, where would 14 miles lie on this graph here? And I would say, well, you know, it would lie roughly about right in here. So if we were to trace this out over to our graph of our function here, I would say that, you know, I've got a good prediction that it's probably going to take about 4 hours. But this is why we were finding the equation. We were finding the equation of her distance as a function of time because what we wanted to do was actually go plug in for y here, 14 miles, and say, well then how many times is 3.5 going to 14? So solving this equation, we'll divide both values here by 3.5, and 3.5 goes into 7 twice, and 7 goes into this twice. So what we end up with here is this. It implies that x is 4, and we should label this as 4 hours. But that's how you write the equation of the line. We'll just go ahead and find the slope first, and we will also just use the y-intercept if possible. Cheers.